Good morning, gentlemen. Good morning.
Good morning.
Good morning.
Oh, good morning, ladies and gentlemen. Now, I'm sorry that we can't meet in person, but anyway, nice to have you here. Now, today's lecture will be broken into two parts. The first will, let's say, be about organizational matters. The second part would be about electromagnetics. So although I understand that you are looking forward to get to the second part, I have to start with the first part. So first things first. Then, of course, we have several organizational matters to decide. One of those is the time of consultations. The second, of course, is the time of the lecture. So let's start with consultations. I need to find some time where I am available and you are available as well. Now, if we can make a short vote on that, I first suggest Monday evening at 5:45 in the evening. I hope that you have no other lectures at that time. If there is anybody who has lecture who can't make it on Monday evening regularly, please raise your hand. You know, in Microsoft Teams there is a small hand. You can raise it like this. So if there is anybody who can't make it on Monday, 17 hours 45 minutes. Of course, consultations are not compulsory, but I will wait. I will always make a meeting in Microsoft Teams. And if there is anybody coming in first 5 minutes, I will do the consultation. If there is nobody, I will log out. So that's the first point. Now, unfortunately or fortunately, next Monday is a public holiday in this country, so there will be an exception. Next Monday there will be no consultation, but we will have the lecture on Tuesday morning. So agreed? Okay. Now there is a second thing which I would like to discuss with you, and that's the beginning of this lecture. According to the timetable of the Czech Technical University Faculty of Electrical Engineering, the lecture starts at 8:15. Now, the lecture ends at 10:45, which is 2.5 hours. We have a lecture composed of 3 blocks that altogether makes 2.25 of an hour. So we have 1/4 of an hour spare in that time. We can use it different ways. We can first start 1/4 of an hour later, 8:30, like today. And then we finish at 10:45. Or we can start at 8:15 and finish at 10:30. Or what I suggest is to start at 8:20, have 10 minutes break during the lecture, and finish at 10:45 according to the timetable. Now, it of course depends on you whether you can make it at 8:20 and whether you want this time slot to be used this way. Now, is there anybody who would not be comfortable with my suggestion to start each week at 8:20, have one 10 minutes break during the lecture, and finish at 10:45? Okay, so I have one in my chat. There is one agreement. There are no disagreements. Nobody raised his hand. That's fine. And so we shall stick to this solution. So next week we start 8:20. Well, we started 8:30 this week, but anyway, we will make a break even this week, because I don't think it is possible to be focused for 3 consecutive time slots, that is 2 hours and more. So we will make a break approximately at 9:30. So that's the first point. Now let's come to other organizational matters, and due to that I will just change my background. By the way, this was my welcome background for you, because this background is the flourishing trees at the entrance of the Faculty of Electrical Engineering at Davis premises. Well, unfortunately you can't be there now, but I just showed the picture. Okay, so now I have a piece of paper, a flip chart, I have a pen, and we can continue with some points. First, I would like to tell you that I'm not very happy to teach distantly, because I can't see your faces at the moment. I can't hear your voice. Why this makes me not very happy? Well, normally if we teach in a room, I can see your face and I can read from your face that what I am telling is difficult for you, and I can slow down or tell it once more. But this feedback does not work now. So please, a lecture is something where we can have interaction. I will make short breaks to look into the chat, but you can also speak to myself if there is a problem and you need me to repeat something or to tell something in a different way. So that's an important point as to the lecture. Now I would like to put down basic information that is mostly contacts. So if you want to reach me, please use my faculty email skvor at Faculty of Electrical Engineering fel.cvut.cz. This is the email I read regularly, and I will reply to, not several times a day, but regularly. Now, this is important. At the moment it's not useful, but anyway, my room is 533 in the B2 block of the Faculty of Electrical Engineering in Davidson. So later, if we are very lucky and there will be a regular education, a regular consultation, I will meet you there. In the modern time, I also have a web page. So if you type into the browser skvor.cz, you would find my web page. This is in Czech, then you click the English flag on there and you get to the English one. For example, there is the information about consulting hours and so on. By the way, I am happy to consult for students. So consulting hours, Monday 17:45 are not the only possibility. If you drop me an email in advance, I would be happy to offer you other times. So this is as to my contact information. Seems I have something in my chat. Okay, welcome. So this is the contact information. Now we are going to the other end of the term. We are at the beginning. Then we will lecture, learn, consult, learn, lecture. But after some time we will arrive to January and examinations. So first you need to come for the examination. We will have normal examinations, hopefully, or examinations in Microsoft Teams. Anyway, there is an important information. The examination consists of two parts. One part of the examination is written, the other part is oral. Whether that is performed through Microsoft Teams or whether that is performed in person is not important at the moment. So, two parts of the examination, written and oral. Now, let's stick to the first part, which is written part of the examination. Then you will find out that the written part always is composed of two parts. 10 theoretical questions, that's the first part, and 3 tasks to be solved. Now the list of theoretical questions, of possible theoretical questions, is already found on our Moodle page. So you know all the possible questions in the first part at the moment. But possibly you do not need to know the answers. That's why we are at the lectures. Each reply in the theoretical part is marked or graded. And you can receive 1 point, a half point, or no point for the reply. All the questions are simple, and I expect 1 or 2 equations or 1 sentence or 1 simple graph. That means that you should not spend more than a quarter of an hour by all the theoretical questions. It's up on you, but I suggest not to write more. I do not expect romance or novels or poems. I expect a brief, exact reply. Then, after this part, there are 3 tasks, and each can help you to get 10 points at maximum. So the total number of points might be 40 at maximum out of the written part. Now, this is the possible amount of points at the beginning. And you can get some part of that, hopefully 40. Now, at the end of the written part, we make a ratio: obtained points over possible points. If you have this ratio over 1/2, you pass the exam and you get E. Well, if you get better ratio, you get possibly D, C, according to the rules of examination at the Czech Technical University. So, for example, from 36 to 40 it's A, from 32 to 36 it's B, and so on. Well, but we still have the oral exam ahead. So you have some ratio of points and you come to the oral exam. Now, there are 2 possibilities. First, you like the mark, the grade, that currently is according to your ratio of obtained over possible points. If you like it, we normally shake our hands, or I will say good, and I will put it into the information system, and the exam has been finished. So I do not ask questions if you do well in the written part. But possibly you want a better grade than comes out from the ratio. Well, okay, then there is a simple rule. I watch your written part for the weakest point. That might be the 10 theoretical questions. That might be some of the tasks, because each of the tasks is selected from some part of electromagnetism. So if you lack knowledge in electrostatics, I will give you a new task, which is electrostatics. Again, of course, a different one from the first. Now, the possible amount is p plus 10. You solve the task and get some points. Let's say you get 7 points. So now your ratio is changed. And in this case, it seems that you improved. But of course, if you have 21 points from the first part, which is barely, but yes, E, you decide to go for D, for example. I give you a task, you go for no points out of the task, then you get 21 over 50, which is fail. So you decide whether you want to go on with the examination. Now this repeats till we know your final exam mark. There is one more limitation. The oral exam could not last for more than 2 hours. In no case. The reason is that after 2 hours of this kind of examining, it is quite unlikely that you are still doing well to improve. So the limitation is 2 hours at maximum. So this is the way we are going to carry out the examination. Now I would like to learn your questions, because it is important that we all know what is going to happen at the end of the term, to be fair. So is there anything unclear to you? You can raise your hand, you can write to the chat. You are not going to have homeworks weekly. However, I will give you from next week some examples of things that you could solve if you want or not. I mean, I will not check whether you did it. You have the consulting time when you can ask me if you do not know how to do that. But I am not going to give you homeworks and check them at the end. No, there will not be midterm tests to get započet or assessment. Well, normally the assessment is given for being present at the lectures. With coronavirus, this is a special year. I do not want anybody to be forced somehow, so we will offer you the possibility to watch lectures, to be at seminars, but we do not make this year it to be a condition for getting assessment. So the only thing that is important, that you get the knowledge. Please use what we give you, and if necessary, come or log in for consultations. But we are not going to be limit to limit you somehow, because some of you might get sick during the term, we still hope to have some weeks with real, I mean, not online education, and we decided not to force anybody to come even if he feels sick, because that could be dangerous for others. So in this special year, you will have no obligation, but please be responsible to yourself and use what we offer. Well, there is a question whether I can save the lectures and seminars in Microsoft Teams. I am not sure that this service would withstand it always, but what I am doing now, that I am independently taking a video of this course. So there I have a computer with Microsoft Teams, and from next part of the lecture I will try to get the recording. But anyway, I have a better camera that is pointing at myself at the moment, and I will yes, there is a question. So yes, exactly, I'm going to upload the video from the camera to YouTube, so you could rewatch it when studying. That's what I am doing. So the camera is running now, even that's not electromagnetics, but you can return to what I am telling to you at any time. I will send you the link to my channel that I use for uploading videos from the lectures. So there will be a continuous set of videos. As I take it in high resolution, it takes some time to upload, but more or less it should be there tomorrow. Yes, okay, so are there any questions, any more questions as to organization of the course? Well, there is one more point. We normally use a book of Haidt, Engineering Electromagnetics. We have even bought 100 books for you, so there are waiting you at the library. But unfortunately, there was a coronavirus case in the library and it is closed for this week. I will let you know next week whether it's better and you can borrow the book, or whether you have still wait. If there is a problem for a long time, we have to solve it in another way. I will test it. But anyway, for the moment, unfortunately, the library is closed due to one coronavirus case. So I hope that next week you will be able to borrow the book, and I will make a note of it at the beginning of the next lecture, 8:20 next Tuesday, that is the 29th of September. So are there any more organizational matters that you would like to raise now? I can't see a raised hand in Microsoft Teams. I can't see any question in the chat. Okay, so that is, I would like to conclude that we have been talking about organizational matters. Things have been cleared, and now unfortunately we can't take a table tour around to learn who is who. So at least my name is Zbigniew Szkwor. I teach electromagnetics. I'm the vice rector for science and doctoral studies, and I work at the Czech Technical University. You can see me now. I'm happy to teach you, and if there is no more question as to organizational matters, we will switch to the beginning, to the introduction to electromagnetics. Now, the last possibility to ask as to organizational matters now, please. I can't see any question, so we will go on with electromagnetics. And as the introduction, as the beginning of the course, we would act like in ball games, in football. You have first to define your playground so that the player knows where he is, whether he is in the game or whether he is just waiting outside, whether the ball is in or out. That's football. So we have to define the playground. What are we going to talk about, and which cases we should be investigating? To do that, we would first think of materials or matter in several different aspects. We will classify materials into different groups. First important property of a material that we will investigate is its behavior against time. You know that some materials change rapidly, some materials change very slowly, and some materials, in fact only one material, does not change at all. The only material, if I can call that a material that does not change as far as we know at all, is vacuum. So in vacuum we have no change, and this type of material is absolutely stationary. Well, a stationary material means that its properties, whatever they are, do not depend on time at all. Now, yes, there is only vacuum that is really stationary, and physics even question that, but anyway, all other materials can or suffer some changes during time. So technically speaking, we will call a material stationary if the change against time during the whole time of our experiment, or say a lifetime of a mobile phone, the material does not change its properties significantly. So that's a stationary. Of course, there is an opposite, a non-stationary material, which changes its properties during time. For example, if we have a bottle of water and we let it freeze and defreeze again, its mechanical, electrical, acoustical, and other properties change during the experiment rapidly. A piece of ice is quite different from a piece or a glass of water. So that's the first way how we classify the materials, whether they are stationary or non-stationary. And yes, it's quite much more easy to handle stationary materials. The other property comes to linearity. What linear in fact means, well, if we have some property or some quantity in that material. If the material is linear, if we put twice much force, we have twice much pressure. If we put twice more voltage, we have twice more current. If we put 4 times more voltage, we have 4 times more current. That's linear. So the result is a linear function of the cause. Now, as we will learn later, this is also an important point, because if we have linear addition of causes, then we can calculate or find out the result of multiple causes, multiple sources, just by adding them, which is called a principle of superposition. But we will return to that later. So linearity is a very important property of materials, and it is more easy to handle linear materials. Of course, there is an opposite, nonlinear materials. This was quite easy. Now we will go on for something which is less easy to understand. So we have linear, nonlinear, we have homogeneous. And of course, the opposite is non-homogeneous. Now this is quite simple. For example, a homogeneous material is, or a homogeneous body is in all its points the same, has the same properties in any point or in all points. Well, it's quite difficult to find a homogeneous body. For example, I have here some coffee, where the coffee is inside this bag, and yes, you will find out that there are some areas of this body, this bag with coffee, that are homogeneous. For example, the wrap, then the closure, possibly coffee beans inside are homogeneous, but unfortunately the world is not homogeneous, or fortunately, because if everything was homogeneous we would not exist as creatures. But anyway, a homogeneous thing is something which is composed of in fact one type of material that is of the same electrical or mechanical or acoustical properties in all of its points. It's homogeneous. Well, the contrary is non-homogeneous or inhomogeneous, and most of our life we spend experiencing non-homogeneous materials, non-homogeneous reality. Well, now there is one point that is really, really uneasy, and that is the fourth, which is isotropic. Well, and the contrary is anisotropic. Now this is not so easy to explain, because we mostly in our lives have the direct experience only with isotropic materials. So what an isotropic material, what's the difference between an isotropic and an anisotropic material? Well, the definition is that the isotropic material has the same properties at any direction. At any direction. Not at any point like homogeneous, but in any direction. Well, we are used to isotropic materials. So let's get an example of a material that is not isotropic and show what it means in reality then, not to be isotropic. Just a technical break. So let's say that we start with something that is anisotropic. Just imagine that you have an old transformer, a big transformer. Its core is composed of metal sheets that are insulated against each other. We will learn later that this is because of reduction of eddy currents that cause losses in the transformer. But now we have the core of the transformer, which is a lot of metallic sheets, and each is separated by a layer of insulation from the other sheet. That insulation might be a paper, the cheapest course, or nitride layer, the most expensive ones. But anyway, we take that core and cut it. We cut from the big core of a big transformer, we cut a brick, and that brick is cut in a strange manner. So it's not cut parallel to the pieces, but it's cut in at an angle. So